Hello and welcome to another AdvancedSkeleton video. This video will be part 2 of frequently asked questions. Now here are the list of the questions that we'll cover in this video. Now if you want to skip ahead to any of these specific questions, you can look in the description below. There are all the questions with links to skip right ahead in the video. Alright, let's start at the top. How to add main controls. Alright, we'll jump over to Maya. We'll build a standard biped rig. And we'll see that the main control is this guy here that moves basically the entire rig. And I'll show you here how we can add multiple main controls. So we'll go ahead and start a new scene. This time we import the biped FitSkeleton and we'll select the root joint. And we'll see that on the fit root joint, there is an attribute that calls number of main extras. By default, that's 0. Let's go ahead and give it a higher number. Let's give it 5 and hit Build AdvancedSkeleton. And there we are. We see we now have 5 of these extra controls. So that's if you're building from one of the FitSkeleton templates. However, if you are creating joints from scratch, which we can do here just with the Create Joint tool, and then we'll go ahead and build this into a rig. And then we'll hit Toggle Fit Advanced to go back to the FitSkeleton. We can see that now, since we built this from scratch, it does not have the main extra attribute. So we can go ahead and add it manually. It's in the Fit attribute drop-down list here. And it's this one called the root options. So we'll go ahead and add that to the root. And we'll see we get those root options. All right, let's go back to our list. Next question, how to set eye rotation range. Okay, to answer this one, we'll just go ahead and open one of the demo characters. Let's grab Tuna. And what is meant with this question is how to set the range that the eye rotates when these controllers are moved. So for this character, you can see that when I move these controllers all the way to the right, that's how much each eyeball rotates. Now there might be times where you want to have different values for this. It depends on how your character is built, how much it can look to the side before the eyes spear into the skin. Now the way this works is that these are actually driving systems. So we'll go to the build pose. We'll go under the pose menu, under the driving system subsection here. And if we hit right click on the edit button, we'll see a pop-up list of all driving systems. And one of them is going to be the control eye. So if we choose control eye translate X value of 1, that is showing us how much it rotates. Now by default, the actual FK eye controllers are not showing, so I'll select the control box and turn on eye control with here just so we can see that. There's the controller and we can see that it has been rotated to the side 30 degrees. If we wanted to change that, say we wanted it to rotate a lot more, just exaggerating, just to demonstrate, we'll type in 50 degrees. If we hit apply, we'll see that this time when we select the eye controllers, move them to the side, they do rotate a lot more. So it's worth noting here that once we set how much it's going to rotate this way, we do not need to set how much it's going to rotate the other way. It's going to be the exact opposite. However, if we wanted to also have the up and down to be rotating the same, so 50 degrees up and down, we could go here, go edit and find that translate Y. But I'll show you here that this edit button has 2 ways of working. One way is right clicking to get the value that you want to edit. Another way is you just set the driver that you want to edit. So in this case, when that controller is fully up, meaning translate Y is set to 1, that's what we want to edit. So instead of finding that in the menus here, we can just hit edit. And we can confirm here in the heads up display on the top of the viewport that we are editing driving system for the control I set to advanced value for translate y equals 1. So by default, that's also looking up 30 degrees. We'll change it to 50 and hit apply. So we now have a much more sensitive controller that will rotate those eyes a lot more. All right, back to our list. Next question. How do I modify the pupil or iris attributes? Okay, this is very similar to how we were setting the eye rotation range. So the iris and pupil, there are actual controllers here that you can scale and manipulate. By default, on most rigs, these are not going to be showing in the view because the default value for the eye control here is set to 0. But we can go ahead and turn it on. And the most common controller for pupil and iris are on the control box here, called the pupil and iris here. Once we change this value, we can see that we can scale up the iris and we can also scale up and down the pupil. Now the question covers, how do we edit this? So for example, if we want to do an extreme scale up for the iris, you can see that the way that works, it kind of scales up this part of the eye and move it back. And once we go too extreme, that's not going to hold up anymore. But if say we wanted to edit how that works, we'll go set the full the value to its maximum in its range, called iris 10. Again, we hit edit on the driving system, and we can see now that when that is set to 10, the iris is set to move back and scale down. Now that's maybe a bit too much for this character, so we'll go ahead and move it a bit back forward and scale it back down a bit. So that is going to reduce the amount of maximum effect for when the iris scale up. So maybe we wanted something like that to be the effect on the max value. So we'll go ahead and hit apply. And that has now become our new effect when applying the iris value. All right, back to the list. Next question. How can I make the rig faster? So making the rig faster, there are standard things that can be done. So some of them are here in the geometry polybox options. And here you can see that you can create these polybox stand-in versions, and you can also use those polybox to do Boolean operations and get more closely related cut-up geometry that runs faster. But one of the main things I wanted to show with this question is that often what happens is that the rig is already faster than you might think. So when we're talking about the rigs being fast, we are usually talking about how many frames per second performance you can get when you are manipulating the rig. So let's go ahead and display, heads-up display, turn on frames per second. This is our frame rate. Now a common way to check if the rig are fast or not is for many just to select the root controller and move it around, and then take a look at the frames per second down in the corner here, and you can see that in this case we're not getting very high frame rate. It's cruising around about 9 frames per second. But it's worth noting, this is not going to be the actual frame rate as you do animation, since Maya has ways of accelerating performance when you animate. Now to trigger these functions that Maya have, to speed up the performance of the rig, there are certain things that Maya does that detects that you have started animating. Now we can do some tricks here to make it detect that. So we'll first go back to bind pose. We'll set some keys here on the root controller. On the first frame, set a key here, go to the last frame, move it over and set a key. And we'll just go ahead and hit play. Now you see what's going on here. All of a sudden we went from 9 frames a second to close to 50 frames a second. So we can see here that by adding some keys on the rig controller, we are getting more close results of the actual performance of the rig. Another even more accurate way to test is to put keys on every controller. And a quick way to do that is to jump here into the selector tool under the animate drop down menu and just open the mocap library. We'll grab the very first motion capture clip that's in the library and hit apply. And we can now hit play, and we see that we are getting about 45 frames per second, and that's with keys on nearly every controller. And to do an even more fair test, what we can do again, open the mocap library and apply the face test animation. So we have animation on the face controllers as well as all the body controllers. And let's hit play. We can see the face and the body animating, and our current performance is about 42 frames per second. All right, we'll get back to our list. Next question, how do I show the joints? All right, we'll make a new scene, open another demo character here. Let's grab a different character, Chubby. Open him up. And by default, when we open a completed rig, we are not seeing the actual joints of the rig. Now they are hidden, and the way to turn them on is fairly simple. You go to the main controller. There's some attributes here to display certain parts of the rig: FK controller visibility, finger visibility, IK controller visibility, so on. And one of them is joint visibility. So we can turn on that attribute. And if we turn off the geometry, we can see that there are the joints. Let's crank up the joint size so we can more easily see them here. So there are the joints. Okay, next question. How to rig non-spherical eyes? So to take a close look, we'll none of the demo characters actually have non-spherical eyes. So we'll go ahead, open tuner, and we will just squash him a bit to give him non-spherical eyes. So first I'll go to the face section, hit toggle, fit advanced, hit delete advanced. That deletes the entire advanced face setup, but it keeps the fitting. Next, what I will do is we will just grab all the geometry here and we'll just go ahead and squash it a bit for now. Alright, our character has been squashed, which looks a bit strange, but it's gonna demonstrate what we mean with non-spherical eyes. So basically we have eyes now that are not a complete sphere. They do look like a sphere from the front view, but once we go to the side view, we'll see that they are much more scaled down. Alright, so if we were to try to build this as a normal eye, we can see that that would not work very well because the eye is rotating as a normal sphere would rotate. And since it's non-spherical, parts of the eye starts poking out through the skin. So that's the question, how do we rig these non-spherical eyes? And the answer is fairly simple. We just gotta make sure that the fitting eye, called fit eyeball, is squashed according to the eye geometry. So by default, the fit eyeball is a sphere. So what we will do here, we will scale this fit eye to match the eye so that the size is about right and the squishness matches. There we go. Display the geometry again. Alright, and this time as we start building, once we get to the eyeball build step, we hit build, we get this pop-up menu. It says, hey, fit eyeball is squashed. Do you want to proceed with creating a non-spherical eye setup? Yes, we do. And there we go. We are now able to rotate the eye. Let's hide all but the eyes for the geometry. And we can see that rotating them allows now for eyeball to rotate, but without penetrating the skin. And if we select one of the balls, you can see it now has a series of lattices applied, which is how it achieves the effect of rotating a non-spherical eye. Alright, back to the list. T-pose or A-pose? Alright, if we do a quick Google search, T-pose. T-pose is what it's called when a model is kind of got its arms straight out and legs straight down, resembling the shape of a letter T. Now this is a useful pose to model a character in for rigging purpose. Now an alternative to that is A pose, where the arms are more on an angle down, and also part of A pose, the legs are often somewhat spread out more. Okay, to clarify, AdvancedSkeleton can rig both types of poses with no problem. You just make the FitSkeleton joints match the model. But the common asked question is from someone about to start a new project, and they're going to be first modeling the character, then rigging the character, and wish to know whether it is better to use A pose or T pose. Now the short answer is I recommend T-pose. And the longer answer is that it depends on your priorities. Now the main reason why one might consider A-pose rather than T-pose is that major limbs such as the shoulders will be modeled in a pose that's halfway between the extremes of its range, and therefore can be somewhat easier to get good shapes for those extremes. Now another reason why T-pose is very useful is not just for the rigging process, it's also for the animation. And what I mean by that is that it's useful for animators to know that an arm straight out represents a value of 0 rotation and straight down means 90 degrees. Now, if this was rigged in an A pose, the numbers can quickly become less intuitive, as a straight out arm would represent 45 degrees. Now, other issues that might arise in an A pose is IK controllers. Do you then wish to align those IK controllers with the limb in a 45-degree skewed space, or do you want them to be world oriented? Which again can make the animation stage somewhat less intuitive, whereas values are not necessarily representing straight angles. So basically, T-pose is the most commonly used and recommended pose. However, A-pose does provide some benefits, especially in areas such as the shoulders, but it might come at some cost, which is that the controller values will not be as intuitive for the animator to be using. Now, I want to show you that there is a way we can combine the two. We can have a model in A pose, yet the controllers having a typical T-pose orientation. And a demo character that is actually using this is Conan. So we'll go ahead and open this one. Okay, we can see here that the model has the A pose. However, if we select the shoulder FK controller, we will see that the rotation values are not 0. Even if we say go to build pose. If we zero out the values, we get a T-pose. Yet, we can see if we select the skin cluster, turn off the envelope, that it is bound. The skinning has happened in the A pose. So the model for this character is in A pose, and the rig comes in A pose, but the values of the controllers are as in a T-pose. Also for the icon controller, if we turn over to IK, we can see that the icon controller and the limb the arm goes to world orientation, meaning translate up is exactly translate up, which is the intuitive way to have controls for animators. So let's look at how this was made. If we hide the geometry and display the joints, and we'll toggle to the FitSkeleton, we can see here that the FitSkeleton is, as expected, lined up with the geometry in that A pose. However, what has been done is that this has been rotated into a T pose prior to the build process. And actually the keys for that are still in here. So basically any fitting gets done here at frame 10, and that gets to match the model. And then we scrub back to frame 0 for any time we want to build. So this rig was built in the T pose. Then after building, the controller was just rotated back down the equivalent amount that the FitSkeleton arm was rotated. And then skinning was done in that pose. And then to store that as the default pose, it's just a matter of right-clicking on the Go to Build Pose button. And that gives us the pop-up option to set the new build pose. So that's how we got these values, that is the A pose, to be the default values. All right, back to the list. Why are some FitSkeleton in 1/10 scale? All right, back to AdvancedSkeleton here. So we'll open the default biped skeleton, and what we'll see here, if we measure the height of this character. So this character is 17 centimeters high. Now, if we open the help image here next to where it says import a FitSkeleton, and this says AdvancedSkeleton works with models of any scale. However, it's recommended to use a centimeter as the unit and have 1/10 of real world scale. So a character being 100 centimeters tall would be 17 units in Maya. Just a small note on the bottom here, this is because Maya does have minimum and maximum scales that it can efficiently work with. So it is fine indeed to scale up this character if you wanted to 10 times this and work with every centimeter in here being as a real world centimeter. In fact, if we import a biped game, you'll see that that actually is the scale of this guy. He is 170 centimeters tall. And that's because the game engines are often configured to work with 1:1 scale. So basically, any scaling works, but if you are working on a large scale production that's going to have large objects such as full sets of houses, streets, and even complete suburbs, working with the 1/10 scale is highly recommended. Alright, next, frequently asked question. How do I avoid the spine from flipping? Okay, let's jump back into Maya. Open a demo character. Let's go with Tuna. Alright, so if you select the IK controller, we'll open up the attribute editor and have a look. There are some additional attributes available on this controller that is not by default showing up in the channel box, as they are not very often needed to be adjusted. But in this case, yes. So what we'll see here is that we have something called the flip axis. And by default, it is set to side. And what this is that if we grab our spine here, we'll go over to the side and we'll rotate him quite extremely into 180 degrees bent spine. And there we can see the flipping issue. Right as I rotate around this zone, we're getting some quick flips happening here as he reaches that 180 degree. Now that is exactly as I said here, the flip axis is happening on the side. So this, if you needed to do this kind of extreme IK animation, you can avoid the flipping happening here by changing the side flip over to a bend flip. At this point, you see we are able to make this rotation here as he is bended sideways The catch, however, is now that we changed the flip from side to bend, is that if we go from moving to the side, we go to what's called the bend, or in other words, forwards. If we apply that same extreme pose on this direction now, the flip has been moved to this axis. And there's our flip. So by default, you can go over 180 degrees, bending forwards and backwards. However, if you find that you do need to animate that sideways past 180 degrees and encountering the flip, then you can change the value of flip axis from side to bend. Next, how to avoid wrist from flipping. Alright, so this is also flipping, but somewhat different issues with a different solution. By default, the wrists is different behavior for the different axes. You can see that our up and down rotation here, we get a sharp bend. Likewise, side to side, we get that sharp bend. But if we do this twist rotation, it does not sharply twist around the same narrow area, but the twist is distributed down the entire length of that forearm. So that's a system called twist bones, which is very useful for areas such as the forearm. So what we'll look at is that the limitation by default is that once you hit 180 degrees, you get a pop. Basically, it flips at this point. Now, the reason why things tend to flip at 180 degrees is because of constraints, such as orient constraint, using a slightly different math approach than standard XYZ rotation. It uses the quaternion maths, which is great for avoiding the gimbal limitations of the standard rotations, called Euler rotations. However, it does face issues such as 180 degree limits. Now first we'll reproduce that flip again, and we'll just look at the values and make sure that that happens exactly at 180 degrees. So you can see the values on this in the channel box here. The flipping is occurring at 180 degrees exactly. Back to default pose, open the selector, and what we got in here under anim is we got a option called twist flip. Opening this, we can determine in here the amount of rotation before flipping occurs. By default, it's set to flipping happening at 180, and we'll now change that over to 360 and hit OK set. Now, this time, we can go ahead and rotate X, and we'll see we get to 180 degrees, and there's no flipping, and we can keep going. So, this is now set to 360 degree rotations. However, there is a catch. This is using Maya's constraint caching system. And to illustrate the limitation of the system, what we'll do is we'll just animate a bit of rotation here. So at frame 0, we'll add a key, we'll scrub up to frame 30 here, and we'll rotate that 100, let's say 200 degrees, well past 180. And if we scrub that time slider, we'll see that works fine. It's rotating, it's hitting 180 and going past, no flip. Now let's try something different. Instead of scrubbing forward to that rotation, let's just jump from 0 to frame 30. We can see that that still looks correct. Now, let's try scrubbing backwards. And we can see that funky thing starts happening. We are getting some weird, strange results, which is not necessarily a flip, it just rotates well past its limits. Not only that, but it's inconsistent. We can see that once I get to frame 0, it's going to jump. And then scrubbing forwards, we are not seeing the same. So basically, this is Maya's constraint caching system. As long as you're running forward in time and viewing every frame, it can keep up. If you make any jumps in time and scrubbing backwards, you get issues. Now there is a cache management system. So basically you can hit create cache that will bake all the constraints. And once it's baked, you will get the consistent results. And also there's an option here to remove the cache. So there is that system that you can use to go past 180. However, there is another, perhaps simpler way to avoid the flipping as well, which is if you have, say, a short animation where you know you gotta rotate past that 180 degrees, what you can do is open the attribute editor, and you'll see for the wrist there's some extra attributes in here. You can dial down and turn off the auto twisting altogether. Now we're not getting any kind of twisting, which just looks odd, but it could be useful for those cases where you need to animate past 180. So we'll put a couple of keys here. We'll start frame 0. We'll key this at 0, and we'll go to 220. And then, as we have turned off the auto twist, we'll just manually put animation on the extra twist. And the value we want here is the same as the rotation, so 220. And there we go. We have a animation rotating from 0 to 220 degrees, flip free, because we are not using the auto twist. We are manually animating the twist. Now, obviously, this is slower and more tedious than the auto twist, but it is a possibly workaround for those tricky shots where you gotta go past 180. All right, back to our list. Is AdvancedSkeleton FaceSetup a BlendShape rig or a joint rig? Okay, the answer is both or either. Or basically, you can choose. If we go to the AdvancedSkeleton FaceSetup pre-section here, we can see that one of the choices you will make here in the pre-section is what rig type do you want to build. We have the option joint or blend shapes, or the third option, which is mixed. Now, more information is, as per usual, the question mark right next to where you choose the option opens the help image. And here's a bit of information, whereas it lists some of the pros and some of the cons with using joints or blend shapes. Now, another common question that's related to this is which one's better, joints, blend shapes, or mixed? Now, the recommendation for most users is to go with the default joints rig type. This one is easier to manage, it's easier to rebuild, it's easier to tweak and configure, and it gives you a better performance for playing back. The case for switching to blend shapes is if you are very comfortable with sculpting and you prefer to sculpt each blend shape target. Now, you might be working on a production that has requirements for a modeler to very specifically model what each shape's gonna look like for the expression. Then obviously you want to work with the blend shape type rig type. Now, the last option is to have a mixed, which could seem somewhat inviting to get just the best of everything and choose that option by default. However, I would cautiously choose this type as it increases the complexity of the rig, meaning things such as rebuilding is no longer as easy, tweaking the expressions is no longer as easy, and also because in a mixed system, the on-face controllers are attaching themselves onto blend shape targets, which means you are going to get a reduction in the playback performance. If you do find yourself in that situation, there is that real option here that called face control detach. That does somewhat help with that, but still, you're not going to get a fast as a rig if you go with the mix that you're going to get with either joints or blend shapes. So basically, if you're in doubt what you should be using, probably joints is what you should go with. All right, next. How to animate past the limits. Okay. We can show that as we got tuner's face here. We can show that. For example, if you wanted to lift the eyebrows up, one way of doing that is use these controllers on the side here. But you'll see once you reached a value of 1, they stop. There's a limit here. Now, the limits for these controllers is set here on the box itself. There's a attribute here called limits. By default, it's on. Once you turn that off, you can go past the limits. These controllers are no longer confined within their little box area, and you go past any limits. Another kind of limit is limits on custom attributes. So here, for example, the squeeze, if we scrub the value, we can see that this one goes from 0 to 10. Now this is a soft limit. It means it stops when scrubbing at 10, but you can type in any higher number. So you can type in 20. You can even key it in 20. And you'll see that the graph editor, the keys are free to move at any range. It is kind of just setting a suggested range. Same for the body here. It's going to have various soft limits, say the fingers. Scrub the value called spread. It's going to stop at 10, but you are free to go ahead and type in higher numbers, say 15, 18, 20, and this looks painful, 30. So the limits that are used, and this goes for most controllers in AdvancedSkeleton, the limits are of the type soft limits, which you can freely overshoot by just typing in a number. Okay, back to our list. How to rig a piston or a spring. Okay, there is an example of a spring in one of the demo rigs, and we'll go ahead and open that, and that's going to be in the monster truck rig. So the trick with pistons or springs, which makes them different from most other standard joints, is they appear to be attached in two ends. And to have a look here how it's done for this rig, we will go ahead and turn off the geometry, turn on joints, and we'll go hit toggle fit advanced, and that's showing us the FitSkeleton. Now these are the springs, they're actually called the suspensions in here, and the system they're using to give the illusion of being attached to both the main body of the rig and also attached to the axle, so attached in both ends, is that it has the added fit attribute here called aim at. And the way to add a aim at attribute is that you gotta select two joints. Firstly, what do you want to aim at? So for example, if we wanted the back wheel to aim at the door here, we would select the door and then the back wheel and hit aim at. And you'll see we get added attributes here that says what do you want to aim at. So for the spring, it's been set so that it aims down at the wheel. Once that's built, you get the effect that it's aiming. And basically, having that kind of aim gives the impression that it's attached in both ends. Alright. Next, why is there a gap between the fingers when the spread is set to minimum? Alright, let's look at that. We'll open a demo character. Let's go with tuner. And take a look at the fingers and set the spread to minimum. You could have a bit of a gap here between the fingers, which might not be what you want, but it just naturally happens as the spread only determines the rotation of the finger joints. But I'll show you here how you can easily close these gaps if that's what you want to do. And that would be by using the driving system. So what is determining the behavior here as you're changing this attribute and that affects the fingers is what's called the driving system. And that's all set in here under the pose menu and the subsection driving system. We can right click on the edit menu to get a list of all the driving systems in the scene. We'll see that we have one for finger here. And we'll go ahead and edit the driving system for the finger spread set to -5. And then we can see that this is what it looks like at -5. By the way, when editing a driving system, if you are keeping on the default values of test animation, test symmetry shown only affected, what happens is that all the controllers are hidden except the ones that are affected by that driving system. Also, you can scrub between the timeline between frame 0 and 30 to see the effect that it has. So here we can see exactly what's going to happen when we apply this driving system of finger spread set to -5. And we'll make sure any changes we're going to make here now, we got to make sure we do it at frame 30. That's when it's at full effect. If what we wanted was the fingers to come closer as we are applying the spread -5, we can just select these guys, move them in closer, and there we go, and hit apply. Now next time, if we are to spread, we can see that the negative spread brings the fingers together. So if we do now, this time make a fist, you can see that those gaps are gone. So that's how that can be done. Back to the list. Why is the rig slow when I start animation? For this one, I'm actually gonna just refer to how do we make rigs faster. This is kind of covering the same issue. And that is, quick recap. Now if you're just grabbing controls in the rig and moving it around, you might get some poor frame performance. However, that's not really indicative of what frame performance you're gonna get in animation. If you wanted the more accurate animation performance, go ahead, add some keys. And then you'll see Maya kicking in its efficient evaluation modes, and you get much higher frame rates. Next, what's the difference between cluster and a SoftMod custom control? Alright. Let's grab a different demo character this time. Let's go with Clary. In AdvancedSkeleton, we have this concept of custom controls. It's got its own section here. Alright, so let's go ahead and look at this. There are two main options of creating controls here. One of them is called create a cluster control. The other is called create a SoftMod control. And there's a little help image here to illustrate what the different controllers will do. But we'll show you here anyway how that they differ. Okay, so both of them, you start off by creating a SoftMod. Now with the SoftMod, you can grab it, move it around, set the fall off type and fall off value to any value that you want. Once that SoftMod is kind of doing the behavior that you wish to have a new controller be doing, then you hit create control. So first, let's look at what happens if we create a cluster control. Give it a name. Here we have a controller, which is a cluster control, and it got its name from how the deformation is achieved. If we select the mesh, you'll see that it now has a cluster attached, which is a deformer type. And we can move this guy around. Go to build pose, leave it there. Now for the other type, which is a SoftMod control, we'll just create another SoftMod here. Okay, that's fine. This time we'll hit create a SoftMod control. Give it a name. Now the first obvious difference here is the difference in the color of the control. The cluster controls are red, the SoftMod controls are green. Now once you start moving the controllers, they look very similar. However, note that the green SoftMod controller has something extra. It has a yellow locator. Now that is specifying the origin of the deformation. So what we can do here, which we cannot do on a cluster control, is we can deform the object. Then we can select the yellow locator and move the origin of the deformation, and thereby creating this wave of deformation effect. So you can see this type of controller, the SoftMod controller, can be quite useful for specific scenarios where you want to get this moving bulge effect. A typical useful area of something like this could be on the throat, if you want to create a swallowing type effect. The effect of swallowing or something traveling down through the throat. Alright, back to the next question. Where is the Simplified FaceSetup button? So this question comes from someone who have been watching some of our YouTube tutorials, such as this one here, FaceSetup for game engine export. Now this is showing the older version of the AdvancedSkeleton face setup, where it was necessary to hit this button called Convert Face Setup in order to convert the complex layers of deformers into a simplified face setup before exporting to a game engine. However, this was only valid for the older version of the AdvancedSkeleton. In the new version, this is no longer required. As long as you have built a face setup using the default option of face rig type joints, then you can just go ahead and export directly to any game engine, which can be done here through export FBX export or through the selector file export FBX. So there's no longer the need for converting the full face setup to a simplified face setup in order to have compatibility with game engines. Next, where are the MetaCarpals? Okay, so what are MetaCarpals? So a quick Google search shows us the image that MetaCarpals are these joints that you find in the hand, which are not the main finger joints that can highly articulate, but these bones that are inside the palm of your hand. Now these joints do not move or rotate as much as the finger joints, but they are there and they do have an effect. So the question, where are they in AdvancedSkeleton, comes from the default biped example template. In this template, these joints are not there. Now instead, most of the finger joints are just parented directly onto the wrist joints. Now the reason for this is that it is a simplification compromise. So in this case, you do get less joints, less controllers, slightly faster rig, but not anatomically correct all the joints. Now to help with this default compromise, the two outer fingers, which is the index and ring finger, do have one parent kind of metacarpal joint right here called the cup. What that does, it gives some of the main capability of the metacarpal joint, which is to cup up the wrist, which is the rotation that you typically apply to your metacarpals when you're trying to hold something in your hand. Now, that being said, in AdvancedSkeleton, you can just go ahead and add your own metacarpals. So if we toggle to FitSkeleton and pop into the edit section, use the plot joint tool, we could just click on the wrist that sets that as the parent, and then just click in the additional metacarpal joints. And then parent the finger to the metacarpals. And if we then hit rebuild AdvancedSkeleton, that gives us individual controllers for each metacarpal. Or there is one more shortcut way. If you start out with this default biped, there is the option here, which is extra limbs. And in this drop-down menu, there is a hand. Now this hand does have metacarpals. So if you just start out with the biped and hit import hand, and you choose to replace the old wrist, then you see that this has individual metacarpal joints for each finger. So we'll go ahead and build that. And let's use the skeleton geometry. And we see that we now have each metacarpal joint as a separate joint with its own separate controller, if you are in need of the extra, more anatomically correct metacarpal joints. Next question, why is the face black after face setup? Alright, these issues tend to happen in the older versions of Maya, so we'll go ahead and open Maya 2016 for this, and we'll bring in the tune-up demo character. So what can happen is that after you run the build face setup, you end up with a face looking completely black, like this. Alright, so a short quick fix to this is you go into the main skin cluster, you turn off deform user normals. another option is that you use a newer version of Maya where this doesn't happen. Or another thing is you go and have a closer look at the model before you run the face setup, and it will most likely have some issues with the polygon normals. So you can make sure that they are all set correctly and are unlocked. Back to our list. Why are areas of the face not deforming with the face setup? So I have prepared a version of Clary demo rig here that has that problem. And how this typically looks is if you grab one of these controllers and move the lips, and this whole lower region of the face is basically not deforming as expected. Now, a very typical common cause for this is that there is weighting in the face, where parts of the face is not skin weighted to the head joint. So to avoid these kind of issues, what you should be doing is before running the face build, which I'll show you here, we can go back to prior to face build by hitting toggle fit advanced and delete advanced. And what's a good idea before starting the build or any of the build steps is selecting the head controller and making sure that you can move and rotate the head and get a good result. So you can see here this is not at all correct. It should be a case where all the vertices that are part of the face should be fully weighted to the head joint. And you want to probably also make a nice smooth transition between the weighting of the head joint down to the neck joint. So a good test is that before you run build face setup, you should be able to select the character and rotate the head and see that all parts of the face are in fact moving along with the head. Alright, last question on the list. Why are some values missing from the DrivingSystem-Edit pop-up menu? Let's have a look at that. We'll go into the Pose section and Driving System subsection and right click on the Edit button to get the pop-up menu. So we'll see here that some of these values are not listed. Let's take, for example, the control mouth corner. We can see that here we can apply translate Y +1 up, we get something, and -1 going down. So you might go in here and go expect to see control mouth corner translate Y +1 and -1. However, we only seeing +1. Now, when this is the case, here we're editing the +1. When we're not seeing the equivalent negative, it is because it is automatically deriving the values to be the opposite. So if we wanted to edit how the -1 looks for the control mouth corner, we could just edit the positive one. So if the positive were to, let's exaggerate this, move even more up, hit apply, we now see that driving that up now moves that further, and driving it down also moves it further than before, because it's automatically getting the opposite. If you wanted it to be different, you wanted the up and down to have different, not just the opposite values, but to be different and unique values, you can easily apply that by just setting what you want to be the driving value, moving that down, hit edit. We can see in the heads up display menu, we are editing the driving system control mouth corner, translate Y set to -1. You might want that to move not as far, and hit apply. We now have different behaviors set for the up and down. So moving it up moves it quite high, moving it down moves it much less so downwards. This is possible, however, I would be cautious about doing it specifically for this mouth corner, because if you do this, moving this control is going to be less intuitive, because it's going to stick well together moving it up, but not so much for moving down. And that's the end of the list. I hope you have enjoyed this video, and I'll see you next time.